everyone, so we're on the second video for measurements and we're dealing with standard units. So refer to pages 13 through 17 of TRO. We're talking about types of units and then specifically for length, mass, time, and temperature. So let's first talk about why units are so important. This is an artist rendering of Tokyo's Space Mountain, their Disneyland, and in 2004 one of the axles had actually broken off of the roller coaster because they had actually ordered the wrong, not necessarily the wrong size, but the wrong unit. So there was a bolt that had a threading, or they were prior to threading, of 1.25 inches, but instead they used 1.25 centimeters. So the axle broke, and the train car itself had derailed. I mean, this fortunately did not have a huge disastrous effect, but we have had many occasions, unfortunately with NASA and a lot of aviation, where using the wrong units have caused not just millions of dollars being lost, but also lives being lost as well. So you need to make sure that your unit, or you know your units. Lives do depend on units as well. So we have two basic types of units used in the world, the English system and the metric system. We're one of the few countries that still use the English system, but the metric system is used pretty much throughout the entire world. And specifically we call them SI units, and this is the French, it stands for this French version. I'm not going to butcher the language, unfortunately, for you. But pretty much the base units, there's specific units used for each one. So for example, length, its base unit's going to be a meter. For mass, its base unit's a kilogram, time is seconds, etc. And each of them have their own specific symbol. So that's the basic unit for each one of them. The beauty of the metric system is you're either timesing by 100 or dividing by 100, or at least 1,000 or 10,000 or whatever. They're super simple to use once you kind of figure out where to move the decimal point. I know some of you guys have used mnemonics like King Henry something or other. I know some of you guys remember. They'll pop back up into your memory, I'm sure. I tend to use the scientific notation just because I can't obviously remember that mnemonic, and it's just easier for me to look at a table like this just to kind of see it. So the first measurement we're going to talk about is length, and that's the distance between 2 points. We use a ruler or a caliper. So on the this image right here is a caliper. We put an object between the two little prongs, and that actually helps us right in here, the two prongs, and using the ruler itself on the caliper, we determine what the length is. The SI unit for length is meters, or little m, and we call it an extensive property because it does depend on how much of that object that you have. Mass is the amount of matter in a substance, so we use an electronic balance to help us with that. And the electronic balance that we use in school generally is the OHAL Scout Pro, and you'll be using it a lot in this course. The SI unit for mass is in kilograms. We generally deal with grams because we have such smaller amounts, and it is also an extensive property. Time measures the duration, this is actually funny, the seconds represents the duration of periods of radiation emitted from transitions in cesium-133 atoms. So we'll talk about electron radiation or emission spectra, but pretty much it's kind of cool because seconds is dependent on an atom that we'll discuss later on, or radiation from that atom. We use a timer to help us out with this, and its SI units are seconds. It's little s. A lot of times I'll write SEC. That's not good of me to do because the actual symbol is just an S. For temperature, temperature measures the average kinetic energy. Underline that, highlight, whatever you need to do. It's average kinetic energy. Temperature does not measure heat. Alright, so make sure you know that. We use a thermometer. In fact, we can use one of these these thermometers down here. They're located generally in your boxes. We take this little red cover off, and this is a digital thermometer. A lot of times we'll use the Vernier LabQuest with a temperature probe attached to it. And the SI units for this are going to be in Kelvin, or big K. There is no degree symbol in here either. So generally in the US we use Fahrenheit. Everywhere else uses Celsius, but for the SI units we'll deal with Kelvin. So kind of quick thing with Kelvin, because that might be a new thing for you darlings. So again, we have Fahrenheit, Celsius, and Kelvin right here. And they're based, well, Celsius and Kelvin are smart. They're based upon like water's freezing and boiling points. So here, the freezing point of water in Celsius is 0 degrees Celsius. Its boiling point is 100 degrees Celsius. that's a 100-degree difference. Fahrenheit, the freezing point's 32, the boiling point's 212. I'm not always a fan of numbers, but I know for me, 0 and 100 is a lot easier to deal with, especially with a 100-degree difference versus a 180-degree difference. With Kelvin, it's still that 100-degree, or excuse me, Kelvin's does not have degrees, but it's a 100 Kelvin difference. In this case, it's 273 versus 373. And absolute zero is really what we want to base Kelvin upon. And we use absolute zero a lot in chemistry because that's kind of how we define the properties of a lot of substances. So if you take a look here, actually, the difference between Celsius and Kelvin is just 273, just that number. And it'll hopefully be easier for you to remember that as well. So to summarize, we use SI units to help us out, and make sure you know each of the pieces of equipment that we'll use as well. Have a good day.